Ladies and gentlemen, please welcome to the stage Program Committee Co-Chair Maria Medeiros.
Everybody, let's get into it. Get stoked, get it started, get it started, get it started. Let's get it started. Let's get it started in here. Let's get it started.
Good morning. We just found out we each have a song, so listen to each song that's been assigned to us. But I'd like to take this opportunity and welcome all of you to Connecticut and the 2012 Fuel Cell Seminar and Energy Exposition. It is with great pleasure that we take this opportunity, Michelle Anderson and myself as co-chairs of the Technical Program Committee, to welcome our distinguished guests, award winners, and of course all of you for attending and supporting the Fuel Cell Seminar. We are celebrating 36 years this year of the seminar, and it continues to be really the premier gathering place for fuel cells and hydrogen industries. And as you'll notice throughout this week, the seminar's technical program has extremely expanded to keep up with the times. And the technical program not only includes fuel cell and hydrogen research and development technologies and demonstrations, but also now showcases many field testing, mature field test systems, and commercial products that are now available. As this year's tracks have changed also to showcase the maturity of fuel cells and the commercial products. These tracks include motive and automotive sector, stationary power, energy production, business-to-business enterprise solutions, and for the first time we've added an educational track. And we're doing this because several universities and colleges are including fuel cell degree programs for many of their students. And we want to highlight that and also provide that information to you as viable potential hirees for some of the fuel cell companies. Along with the exciting 3-day technical program that we've put together, we also have 3 plenary sessions. Each morning we'll have one. Today's topic plenary session will be on market value propositions for fuel cells. Tomorrow it will be on natural gas, the bridge to the future, and on Thursday it'll be state of the industry. As in the past, the fuel cell seminar also includes an exhibit hall. Please take your time and go through the exhibit hall. It's really packed this year, and it's wonderful to see that. And this will actually be your opportunity to see and touch fuel cell systems and learn more about how fuel cells are being used throughout the world. The seminar will also feature a ride and drive, and it's back, and we're very excited that this opportunity is back, and sign up to do a ride and drive in a fuel cell car. And for the first time, the exhibit hall will also have a fuel cell Model T automobile available, and it's provided. It was a student program from Rhode Island, and you get to talk with the students and learn how they put this fuel cell Model T automobile together, so don't miss that. A poster session is scheduled for Wednesday between 4 and 6 p.m. This is actually the first time that we've dedicated a session for the posters, and there will also be poster award presentations announced on Thursday during the luncheon, the award luncheon. And that, again, the poster session is Wednesday, 4 to 6 p.m. And the posters, please set up your posters today by 5 p.m. and the posters will be set up for your viewing until Thursday at 1:30. And as in the past, this year the 2012 Baker Student Awards for Fuel Research will be announced on Thursday at the award luncheon. And this is the first year we're incorporating the first and second prize winners in the technical session. These students will be presenting their research efforts in the technical session. So make sure you stop by that technical session where the two first and second prize winners are taking place on Thursday on the research and development session from 2 to 4 p.m. A welcome reception will take place this evening from 5 to 7 in the exhibit hall, and the industry reception will take place tomorrow between 6 and 9 p.m. at Margaritaville. We're also including 2 luncheons that are provided as part of your seminar, today's luncheon, and again on Thursday the award luncheon will be provided. And you're on your own for lunch on Wednesday. And as Michelle and I, as co-chairs of this year, we have a long list of people to thank that helped us make the seminar a success. And we would like to start with thanking the Technical Program Committee for their diligent work in putting the technical session program together. We'd also like to thank the session chairs that we've volunteered to help us throughout the week. We would like especially to thank the Board of Directors for their vision of this fuel cell seminar and expanding the seminar to track what industry and what the world is doing in fuel cells and energy. And of course, all of the sponsors and the exhibitors in the exhibit hall. And we also like to take this opportunity to thank the management team at the South Carolina Hydrogen and Fuel Cell Alliance for all of their program technical committee put together the programs and all of the emails that you received, all of the announcements, etc. Especially Nancy Martinage, she's been very helpful in helping us throughout the year. We'd like to congratulate all of the award winners. You'll hear from some of those award winners this morning and again on Thursday. So congratulations to all of them. It's a great opportunity to listen and to hear their vision of fuel cells in their particular fields. Please take a minute to look at the updates and the changes that have been added to the program. It's the green leaflet, so there are session update, technical session updates, there are presenter changes, and session chair updates, and also poster session changes. So please take a minute to look at that. So if you have a particular session or presentation you're interested in, make sure it's still on for today. So again, it's a great pleasure to be here. This is a wonderful venue. As most of you know, the Mohegan Sun also has a fuel cell as a backup generator, and it's been going, I believe, for 90,000 hours, and I think you'll hear more about that. So that's very exciting to hold the seminar in a venue that supports fuel cell and its industry. I hope you have a wonderful week. As I mentioned, the program is fully packed, from technical talks to posters to plenary sessions. Take advantage. It's a great opportunity to network and to see what else is going on in the world in the fuel cell and energy community. And now I'd like to introduce Shannon, and she will be providing additional remarks on the expansion of the fuel cell seminar. Thank you.
Please welcome to the podium Fuel Cell Seminar and Energy Expo Board Member Shannon Baxter Clemens.
It's win, 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 no matter what. Got money on my mind, I can never get enough. And every time I step up in the building, everybody hands go up. And they stay there, and they say yeah, and they say there.
All right, so maybe everybody wasn't familiar with the song. I'm kind of new to it too, but I really like it a lot. I work with the South Carolina Hydrogen and Fuel Cell Alliance, and I'm also a board member with the Fuel Cell Seminar and Energy Exposition. So if you look on your badge, you'll see the old logo for Fuel Cell Seminar. And this is just because we hadn't got them changed over. But then if you look in your program, here's the old logo. And you're very familiar with that, 36 years. I can remember years ago wanting to go to Fuel Cell Seminar because it was only every 2 years. I had to go that year, and I think we didn't have the budget to go to it. So I was pretty excited when I did start going, and then you'll recall that Fuel Cell Seminar became an annual event. And then we have we've started a transition a few years ago under the direction of Board Chairman Sam Logan. And Sam is no longer our chair anymore. Mark Williams is now the chairman of the board of Fuel Cell Seminar and Energy Exposition. But something that was a vision for Sam and for the board that we have now is to move from a way of thinking of fuel cells being in a research mode and start thinking about moving them into the commercial world. Start thinking more in terms of how do we make this a reality for more people? How do we enable the industry? And we kept hearing from folks, this is what was wanted. And so if, Nick, would you put up the new logo for me? If you turn to page 3 in your program, you can also see the new logo. So we've modified the name. It's gone from Fuel Cell Seminar and Exposition to Fuel Cell Seminar and Energy Exposition, and this year we're featuring hydrogen fuel. You heard Maria talk about the way the tracks have evolved. I mean, for how many years did we do PEM, solid oxide, molten carbonate, and then the commercialization. So this year it's a much more descriptive set of tracks. It's a lot more current. It's just a whole facelift on the whole group, I'm hoping you'll feel. The new vision for Fuel Cell Seminar is that the Fuel Cell Seminar and Exposition is the premier international gathering of the fuel cell and hydrogen energy industries, their customers, and stakeholders. And we are doing this through partnerships. We are partnering with a number of groups now. One of them is, you'll see on Wednesday, that Plenary is a partnership between Drive Natural Gas Initiative, which includes ANGA, American Natural Gas Association, and the American Gas Association, AGA. Then on Thursday, we have another plenary that's another partnership with the Fuel Cell and Hydrogen Energy Association. And I think most of you know that the Fuel Cell and Hydrogen Energy Association is where the Fuel Cell Board and the National Hydrogen Association Board merged. So we have a strong partnership with this group, and Maury will be here. Maury Markowitz, Executive Director of FCS&EE, will be here on Thursday speaking, as well as Mike Hicks, who is the chair of the board over at FCS&EE, and he's also the treasurer of the Fuel Cell Seminar Board. So we're doing more to make this a great conference for the industry. I think some of the ways that seems to be happening is the conference is growing again. The conference numbers had been going down. Everybody smile. Look like you're really happy. So the numbers of Fuel Cell Seminar had been going down for about the last 5 years. Every year the conference was getting a little bit smaller. This year the numbers are growing. As of yesterday, we already had 941 people signed up. Last year we peaked at about 900. So this is before all the on-site registrations that go on today, all the people that register for the ride and drive. We have a lot of on-site registration normally, so I don't know what that final number will be, but I feel certain it'll be over 1,000. And so that's just great news for our industry. That's a great way for us to come together, to talk, to think about ways to just make this more of a reality, because, you know, being election day, our country needs this. I don't know if they know it or not, but they need us. I don't know if you've heard Jeremy Rifkin talk. He was at WEC, and one of his pillars is the hydrogen infrastructure. It's how the hydrogen is used in a high-efficiency way with natural gas. So I think a lot of the issues going on in our country right now could be resolved if hydrogen fuel cells were a bigger piece of the economy. But that's just my opinion. And I think you might hear the same from some of our speakers today too. The ride and drive is back, like Maria said, and there's an effort to go to the top 5 fuel cell states in the country. And so this year we're in Connecticut. Next year we're going to another, that's right, yay, Connecticut, connecting Connecticut. That's what we're doing. And then next year we're going to another top 5 state, and I have a feeling that the year after that we're going to another top 5 state. So we're going to where the work is being done. We're not just going to the same old places we always go that there's really, you know, not that big of an emphasis on hydrogen and fuel cells. I would like to thank a lot of folks today that have helped partner with us. And the board of directors, if you are around and you want to raise your hand, I would appreciate it. Our board chair, Mark Williams. Frank Wolak from Fuel Cell Energy is here, and he is our vice president. Mike Hicks is our treasurer, and Aaron Lane, one of my good friends, is the secretary of our organization. The program committee, these are all listed on page 2, is a number of folks that you can read their names. We have an advisory committee. This is the second year the advisory committee has met, so it just brings more people into making Fuel Cell Seminar and Energy Exposition a great place to get together. And these folks, you know all these names: Klaus Bonhoff, Adrian Corliss, Jennifer Ganji. Who does not know Jennifer Ganji? If you don't know Jennifer Ganji, you should meet Jennifer Ganji. I can tell you that right now. She's awesome. Mike Hicks, Fred Humes, Aaron Lane, Maury Markowitz, Mike McKay, Joel Reinbold, Sandy Thomas. That's another one. If you don't know Sandy Thomas, you need to meet Sandy Thomas, because he's got a great email system that he sends out to let you know what things are going on. Mark Williams and Frank Wolak. Our conference chair, I am just tickled that we have Tom Sullivan as our conference chair this year. I'm telling you, if you've never heard this guy talk, if you've never heard his story, you're in for a ride, because it is amazing. I'm really excited about this. Ross McCurdy is our education ambassador. And then I also want to thank the Alliance staff: Brittany Brown, Katie Mixon, Anna Newell, Dana Dawson, Nancy Martinick, an amazing group of women that have come together to put this conference on. If you need something, you find one of us, you're probably going to get it done, if there's any way to do that. And then I'd also just like to say thanks to Sam Logan. So our next speaker today is the one I just bragged about, and I think you guys are going to be really excited about hearing Tom talk. He is, you know, people throw this word entrepreneur around. Everybody wants to be an entrepreneur. I mean, just watch this guy. Just watch him since he was a kid. I've heard him talk. He began Lumber Liquidators, which I think all of us at this point have heard of, in 1996. And then in 2008, he bought Proton. And we were all familiar with that. Now it's called Proton On-Site. And I recall from hearing him talk one time that he did one day of due diligence and was convicted that this was the right thing to do. And then I recall at that same talk, he gave out scholarships. And he was only supposed to give out one scholarship for $100,000, and he gave out 10. 10. All right, so $1 million of scholarships for kids that are doing research in hydrogen and fuel cells. People were in tears. I'm not lying to you. It was so touching, especially the parents of those kids were in tears. They were very, very happy parents. So with that, I am not going to go into any more of this bio that's in here. Read it. You are going to be wowed, and I think you're going to be wowed when you hear Tom talk today. So Tom, we're happy to hear you today.
Please welcome the 2012 Fuel Cell Seminar and Energy Exposition Conference Chair, Tom Sullivan.
Thank you very much, Shannon. Good morning, and welcome to the 2012 Fuel Cell Seminar and Energy Exposition. A record attendance, I hear, so we're on the right track. It's a great honor to be here, especially with all you smart scientists and engineers. The most surprised to see me here would be my science teachers in high school. But don't worry, you're safe. They don't let me near the hydrogen. I would now like to introduce you to the President and CEO of the Connecticut Clean Energy Finance Authority, Brian Garcia. Welcome and go hydrogen. Thank you.
All right, thank you, Tom. And good morning, everyone. It's a great pleasure and honor for me to introduce Commissioner Catherine Smith this morning. Catherine is the Commissioner of the Connecticut Department of Economic and Community Development. Her department is the lead state agency responsible for attracting and retaining businesses and jobs, revitalizing neighborhoods and communities, expanding affordable housing opportunities, and fostering appropriate development in Connecticut's cities and towns. The Commissioner's top economic development priorities are to strengthen Connecticut's efforts to nurture and drive innovation, effectively promote and market Connecticut's many business advantages within Connecticut and beyond its borders, and place a renewed emphasis on all aspects of customer service in order to make Connecticut more business-friendly and attractive for investment. Commissioner Smith is also the chair of the Connecticut Clean Energy Finance and Investment Authority, the first state-level clean energy finance authority in the country. In her role as chair of the Clean Energy Authority, her mission is to achieve cleaner, cheaper, and more reliable sources of energy for Connecticut while creating jobs and supporting local economic development. Commissioner Smith brings her distinguished private sector career in the insurance and financial services industry into the public sector with the governor's appointment of her in April of 2011. She began her career at Aetna in 1983 and held various management positions, including investment officer and chief financial officer for Aetna Financial Services. Later at ING, she served in numerous leadership positions, including Chief Operating Officer for ING U.S. Financial Services and CEO of the U.S. insurance businesses. In 2008, Commissioner Smith was named CEO of ING U.S. Retirement Service, one of the largest defined contribution plan managers in the United States, with more than $280 billion in assets under management and administration. Please join me in welcoming the Chair of the Clean Energy Finance and Investment Authority and the Commissioner of the Department of Economic and Community Development, Catherine Smith.
Please welcome Commissioner Catherine Smith.
Good morning, everyone. Happy Election Day. How many people have been out voting already? I'm wearing my sticker. I know some of you, thank you all for voting. I know some of you are here from out of state, and I hope you voted early, and not often, but early. And we are delighted to have you here in Connecticut. You know, it's Brian, thank you very much for your kind words. It's really been a pleasure to work with Brian on the Clean Energy and Finance Investment Authority. We've really completely changed that organization to be what I think is going to be, well, first of all, we think one of the first green banks in the entire country. And I think it's going to be a new model for how government can be involved and leverage private sector dollars into making investments in alternative energy sources. So we're extremely excited about it. Brian has been at the helm for about a year, I think, something like that. And already we've really shifted the mission away from really being a subsidy provider of energy or of financing for energy companies into being much more of a financier of these kinds of efforts. And I think that will suit all of us much better in terms of the ability to get more of the public money to work in more places. So we're excited about being part of that whole effort. And it certainly is a very important part of our economic development strategy here in the state. I wanted to welcome you, and I know the governor was very much hoping to be with us today to welcome you personally. As you might expect, over the last week, he's been a little bit sidetracked by Sandy and all of the aftermath of the storm here in the state. And while we were not the hardest hit of states, the devastation along the coast is really something. I think we've made a lot of progress in the last week under his leadership, with very few people still without power in the state, but still 2,000 houses on our coastline were completely destroyed by the storm. So we have people looking for homes and, of course, polling places getting opened and all kinds of other things happening. So please excuse him for today. He does send his greetings, and he really wanted to make sure that I let you all know how sorry he is not to be here today. And I think he's very sorry because of the importance of this part of the economy to what Connecticut is doing to make sure that it's got a vibrant and very effective economy here in the state. Under the governor's leadership, we have made a huge strides in developing a great strategy for moving forward, one that is going to turn the tide here in the state of having no job growth for the last 20 years into focusing on those industries where we can really make a difference due to the knowledge-based work skills that we have here, and we are second to none in the state, amongst states in terms of engineers, PhDs, master degrees, and all sorts of very, very smart people who can figure out how to get underneath some of these problems. But we also have a great quality of life here. We have a very productive workforce, and I think that's one of the reasons we're seeing such great interest in some of these alternative fuels here. Finally, as you know, we have terrific institutions of education here, many of which are leading the edge areas for making some discoveries and doing the research that's really required to move us forward on alternative energy, on bioscience, and other things. So the fuel cell industry in particular, amongst our alternative energy sources, is something that the state is very much focused on moving forward with. When I came into office 18 months ago, I took a look at the economy of the state and said, just like I would of a business case when I was back at ING and Aetna, I said, what's working for us, what are the strengths, what are the weaknesses, what are our opportunities, and how should we move our economy forward? And there was no doubt that this segment of the market, while small, relatively speaking, compared to our insurance and financial services sector, compared to advanced manufacturing in the state, and compared to healthcare as well, while it was a little bit smaller, it certainly had a huge amount of opportunity for growth. And I say it's a little bit smaller, but frankly, we have an incredible foothold here. Just the fuel cell and hydrogen industries alone employ 2,700 people here in the state, which is 30% of the national fuel cell industry and 47% of the region. So we clearly did make the top 5, Shannon. Thank you very much for including us. Yeah, thank you. I like the applause in the front row. We also generate revenues here of $600 million a year in this industry, and we are absolutely committed to helping that segment of the economy grow. The fuel cell deployment in Connecticut includes 12 megawatts of capacity, and that number is likely to increase as we see a variety of new programs through Connecticut Clean Energy Finance and Investment Authority, as well as through my own agency, the Department of Economic and Community Development. Now, you all know better than I do how important energy is to our economy. You know, yesterday I flipped on the TV and I saw Jack Welch talking about his view of what's driving the economy going forward, and he put energy in a category along with what he said, similar to what we saw in terms of the wave of technology and its impact on our economy in the 80s and 90s. He views energy as being in that segment on a go-forward basis, and I happen to agree with him. Well, we have natural gas coming in, which will lower the cost of energy and make things, I think, give the country a little bit of legroom here to get some other things done. I think this is the moment when alternative fuels are going to start taking a front seat to economic development and growth, and that's one of the reasons we're so committed to investing in it here in Connecticut. Now, I mentioned Hurricane Sandy, and it's been very devastating for a number of companies, lots of individuals, etc. But I think one of the other things that Hurricane Sandy points out to us is how important it is for things like fuel cells to become a part of our economy going forward. 3 small examples here in the state over the last couple of days or couple of weeks. Whole Foods and Price Chopper markets and super stop and shops powered by fuel cells around the state were able to keep open and keep their customers with provisions over the last week or 2. The South Windsor High School provided an emergency shelter for local residents who have continued to use that school in the wake of the natural disaster. And by the way, in the wake of, we had a few of them last year too, in the wake of those two natural disasters last year, as a place obviously for safety and comfort and warmth. And Carla's Pasta, who I understand some of you saw in the tour yesterday, a great business here in the state of Connecticut that is utilizing a fuel cell, has obviously stayed up and running and also been able to keep up with the demand for its business. And in fact, you know, one of the things I want to spend just a minute on is our overall comprehensive energy strategy here in the state. One of the things we're looking at through that strategy is finding a way to start moving towards and piloting some microgrids. Why? Because we certainly have seen in the Northeast in the last few days how important it is for, how connected, first of all, we all are to this gigantic grid that we all live and die by every single day, whether it's up or not up. So I think microgrids will give us a real opportunity as we move forward to have communities be able to be in charge of their own destiny around energy and the way that they use it. So it's one of the things in our comprehensive energy strategy that we're going to be piloting in the next few years here. And let me just step back and say that the governor himself has been very personally involved, along with our Commissioner of Energy and Environmental Protection, Dan Esty, in devising a strategy that I think is again, second to none with other states in terms of thinking ahead about our energy usage and our energy dependence and how, in fact, we can provide affordable energy to our constituents here in the state. In the first legislative session that took place under the governor's leadership, there was a passage of a bill, it's fondly referred to as 1180, which was created a comprehensive energy plan for the state. In fact, it was the legislation that allowed the Connecticut Clean Energy and Finance Authority to be created and really change in its direction towards this green bank notion that now Brian is in charge of. But it also set out a number of other goals for the state. And one of the things that it required is that we do, in fact, come up with a comprehensive energy strategy that was designed to create jobs, to sustain our business environment and competitiveness, and improve our environmental conditions. So just this fall, the governor and Dan Esty actually unveiled what we're calling a draft comprehensive energy process or program to allow our residents and our businesses to weigh in on how we're going to go forward. And if you look at the state today, you'd see that our energy cost as a percentage of business cost, for example, is pretty high relative to other parts of the country, and certainly pretty high relative to other parts of the world. So one of the things we really wanted to do was to ensure that we could find not only cleaner energy, not only more reliable energy, but also a lower cost source of energy for our businesses and our consumers. So this comprehensive energy strategy, which looks forward, by the way, all the way to the year 2050, it really takes a very hard look at all of the aspects and all the opportunities we have in the state. And of course, we're a state that doesn't produce electricity on its own. We don't have natural resources other than the fuel cell industry. We don't have the natural resources here to build our own future for energy. So it's very important that we find other alternative avenues. So the draft energy plan commits to an energy future for Connecticut that focuses on the availability of cheaper, cleaner, and more reliable energy. And we really do want to reduce costs for residents and businesses, making us even more efficient and effective and competitive in this region and in the world. We also believe it can be very helpful to create middle-class jobs and make it part of our economic development package, improving the quality of our lives by reducing emissions and other types of environmental influences. So I think we feel very comfortable with this strategy, and I think fuel cells will be a cornerstone of that strategy. And as I mentioned, we really expect and hope to work through with microgrids and other sources of localized energy in order to be able to produce, again, not only that cheaper, cleaner fuel, but also a more reliable source of energy going forward. So as I mentioned, you can't have an economic development strategy without having all the pieces of the puzzle working for you. And just one last story, and that is that a year ago when the governor first appointed me, he and I went around the state and we met with about 400 or 500 business owners from the state of Connecticut. And we talked to them about what was working in state policy, what was working in their environment, and where they saw opportunity for improvement as we went forward. And one of the things we clearly heard is that this issue of energy was extremely important. Talent, the cost of doing business, the source and stability of energy were clearly things that are really much on the minds of our business leaders here in the state. So this component of our energy process, the Clean Energy Comprehensive Strategy, the Clean Energy and Finance and Investment Authority, all are critical parts of what we're trying to drive in Connecticut. We're delighted we have such great companies here that are focused on fuel cell, and we want to help them in any way that we possibly can. And finally, I just want to thank you all for joining us here. If you're interested in reading more about the strategy, you can find the strategy at ctgov.energystrategy. And there's the summary, the executive summary. It's quite readable and I think very helpful to understand a lot more detail around what we're talking about. So I wish you the best in the next couple of days. If you need anything, you can also find a lot of information about the state at ct.visit, which has a lot of tourism sites and other things in the vicinity for you to do. But again, thank you very much for making Connecticut your host for the week. We're delighted to have you, and if there's anything we can do to be of assistance, that's what we'd like to do. So thank you very much.
Please welcome the 2012 Fuel Cell Seminar and Energy Exposition Board Chair, Mark Williams.
While they can share the night, it goes on and on and on and on. Strangers waiting.
Well, I like that music. Well, thank you, Commissioner Smith, for all you do for fuel cells in the state of Connecticut. We really appreciate it. Now we got to get down to the business of making a couple of awards. We'd like to make the announcements for the 2012 Fuel Cell Seminar and Energy Exposition Awards. There are two awards given each year, one primarily for technical contributions and another primarily for commercial and policy contributions. This year's award winners are Dr. Eric Waxman, the University of Maryland, and Mr. Robert S. Walker, retired congressman from Pennsylvania. Well, Dr. Eric Waxman is director of the University of Maryland's Energy Research Center, and he's a centennial chair in energy research with appointments in departments of material science and in engineering. Eric is he's a little far from home. He's a Bay Area star. He received his BS in chemical engineering from the University of California at Berkeley, and then he went on, for some reason, to get his PhD in material science and engineering from Stanford University. Dr. Waxman is an elected fellow of the Electrochemical Society and the American Ceramic Society for his technical contributions. He was chair of the High Temperature Materials Division and member of the board of directors of the Electrochemical Society. He currently chairs two important committees for that society, the New Technology Subcommittee being one of them. In addition, he's the editor-in-chief of Ionics and the editor of Energy Systems. He was the former editor of the Journal of American Ceramic Society. He's a member of the American Chemical Society and the International Society for Solid-State Ionics. Dr. Waxman's research has focused on solid ion conducting materials and electrocatalysts, and it includes the development of solid oxide fuel cells, ion membrane reactors, and solid-state gas sensors. He has over 200 publications and 8 patents in ionic and electronic transport and their catalytic properties. His technical contributions include developing some of the highest power density solid oxide fuel cells in the world. He's been a long-time contributor to the Department of Energy's reports such as the Fuel Cell Report to Congress, the National Science Foundation's Fundamental Research Needs Report, NATO's Report on Advanced Energy Systems, and the National Academy's Report on Global Dialogues of Emerging Science and Technologies. Eric is also a member of numerous boards and was appointed by the Governor of Maryland to the Board of Directors of the Maryland Clean Energy Center. It is my pleasure to award Eric Waxman Fuel Cell Seminar and Energy Exposition Award.
Which hand do you want to do? This one?
Please welcome,
Pictures over there? All right.
please welcome the 2012 Fuel Cell Seminar and Energy Exposition Researcher Award winner, Eric Waxman.
She blinded me with science. She blinded me with science.
I actually remember when this song first came out. Remember when MTV actually did music videos? So there are my slides up there. Thank you, Mark, for this award. It's been a pleasure knowing you this last many years and working with you, and I hope to be able to continue doing that. So I've been tasked with giving sort of an overview of the research we're doing, and I want to start off actually rather with the research, but rather on the policy aspect of that. And I assume that most of you in this room are familiar with the Department of Energy's Quadrennial Technology Review, the focus on stationary and transport, supply, demand, etc., and fuel cells and their role or lack thereof in the document that came out of that. One of the things that's rather unique in my ability coming from or coming to the University of Maryland, being at a university actually inside the Beltway, was to try and participate not only in the science aspect, but some of the policy aspects of that regard. And so, oh, it went to sleep. Oh, there it is. I'm looking at that one down there. And so writing papers, talking to at the time, Arun Majumdar and others, as far as the role of solid oxide fuel cells, and pointing out in fact that the fuel cells are a unique technology that actually the only one that addresses all 6 of the key strategy areas. The program that supports solid oxide fuel cells, SECA, which really addresses large-scale power generation, as well if you consider distributed generation as far as helping the grid, was in fact zeroed out in the Department of Energy's budget 2 years in a row. And I argued that rather than zeroing out the budget, this one should be maintained, and in fact, there should be an increase to try and develop lower temperature solid oxide fuel cells to cover the spectrum. So my talk today is about our attempts and efforts at lowering the temperature of solid oxide fuel cells. Now, there's been a big focus over the last couple decades to bring temperature of solid oxide fuel cells down to below 800 degrees C, the primary reason for that being to be able to use metallic interconnects to lower the cost and result in greater reliability. But I want to drive it farther. Okay, I want to get below 600 degrees C for a variety of reasons as indicated here, from easier sealing, smaller thermal mismatch, less insulation, but also rapid startup with less energy consumption, because this really opens up new opportunities in residential, portable power, and transportation applications. But if you look at that plot of conductivity versus reciprocal temperature, you'll see that you can't achieve that with Y as Z. It just doesn't have the conductivity. You need to develop higher conductivity electrolytes. And so this has been one of the focuses of my research for, well, 25 years now. Going back to actually the first fuel cell seminar that I attended in Long Beach, I believe it was 1984, I gave a presentation on ESB, at least it was a poster because I was only a grad student at the time. And the ability to stabilize specific oxide had the highest conductivity of all of the solid oxide electrolytes, but had a number of different problems, and because of that, industry kind of ignored that material. But I never gave up. I don't give things up. I keep working at them. I never throw them away. My wife thinks I'm a pack rat. And I focus on how do I increase that conductivity? How can I modify the lattice, looking at the different cations, their polarizability, their radius, and things of that nature, to try and understand how that impacts the conductivity, the migration of oxygen ions through the lattice. And from doing that, we developed a new electrolyte, dysprosium tungsten stabilized bismuth oxide, which basically has 3 times the conductivity of the ESB, 100 times that of YSZ, and really is, to date, the world record highest conductivity solid oxide electrolyte. Moreover, we were able to find particular compositions that allow us to tailor the conductivity for different operating temperatures. And in fact, this material has high enough conductivity for solid oxide fuel cell applications down to 300 degrees centigrade. Moreover, we could use that approach to demonstrate that we could produce higher conductivity ceria, and I'm sure at some point in the future, if we get the opportunity, we could look at zirconia. The problem with these materials is that weak metal oxygen bonds lead to high conductivity, but they also result in low thermodynamic stability. With the case of the ceria, what it does is it gets high electronic conductivity at low oxygen pressures of oxygen. And in the case of bismuth oxide, it just decomposes to metallic bismuth. So quite some time ago, again going back to my graduate student days, I came up with the concept of a bilayer electrolyte, where we would take two thermodynamically unstable materials that are both highly conductive, a ceria layer and a bismuth oxide layer, and we put the ceria layer on the fuel side and the bismuth oxide layer on the air side, and we would be able to, by modifying the relative thickness of those two layers, develop a composite which was stable and would block the electronic conductivity inherent in ceria. Now, as I mentioned, I did this back in the 1980s, and then I tried to find funding for it. And I went to the Department of Energy, Fossil Energy, which was focused on solid oxide fuel cells, and they said, well, this is a new material. This is fundamental science. Go to the Office of Science. And I went to the Office of Science, and I explained it to them, and they said, well, this is too applied. You're going to make a fuel cell. Go to Fossil Energy. So I tried EPRI and GRI, and finally, those of you who have been in solid oxide fuel cells for a long time remember Kevin Christ. At one meeting of the Electrochemical Society, he said, you know what, Eric, I've got $100,000 left in my budget. It's not spent this year. Send me a proposal next week, and I think I can get it in this year. So we demonstrated that it worked. We filed patents on it, and finally, over a decade later, I was finally able to publish it. And, you know, those of you who know John Goodenough from the battery world will also know that he's also very active, or was at one point, in solid oxide fuel cells. Turns out he came with the exact same idea sometime after I did and tried pitching it to Kevin. And Kevin had to tell him that, sorry, I'd already done it. And I got a real nice email from John Goodenough, which I treasure to this day because of all of his contributions in ion conductors, for congratulating me on beating him to it. So. And to show you how this works, this basically is the open circuit voltage for some anode-supported solid oxide fuel cells based on ceria, and then various different thicknesses of bismuth oxide on top of that. And you can see that by tailoring the thickness of these two layers, we're able to achieve near theoretical open circuit voltage with, again, two materials that by themselves would be unstable. And we know that we can increase that open circuit voltage and therefore increase the efficiency of the cells by basically modifying the relative thickness of those two layers, and that's one of the work that's underway right now. We've also pioneered the use of focused ion beam SEM to understand the microstructure on solid oxide fuel cell cathodes, and these are actually SEM images which are phase contrasted for the pore and solid phase. And you can see the reconstruction of that now. It's not a cartoon, it's an actual solid oxide fuel cell cathode. The orange is the cathode phase, the blue is the pore, and the orange and blue is the interface between them where the gas would adsorb. And in fact, then you can actually quantify the tortuosity of the oxygen molecules that traverses through the gas phase, down through the pores to what's called the triple phase boundary at the cathode electrolyte interface right about there. Now, besides making nice computer graphics, it allows us then to quantify the polarization resistance, which is the scale on the y-axis, versus the microstructure, which is on the x-axis. And it was really the first ever direct quantified relationship between cathode microstructure and performance. And you can see a nice linear fit on logarithmic scale between these two parameters. If you consider the actual oxygen reduction reaction that occurs on lanthanum strontium manganate, you'll know that the current is proportional to a rate constant and the concentration of species. And if I take that in consideration, I can calculate that the charge transfer resistance is proportional to a rate constant and a triple phase boundary length to the minus 3.5. And it turns out that's exactly the slope that we obtain. So this type of approach allows us to design new cathodes with a priori knowledge of what the effect of microstructure is going to be on performance. The only thing we need is to be able to get the rate constants. That's a material property. So in that regard, we also then pioneered the use of catalytic type techniques to obtain that. And we use temperature programmed oxidation, temperature programmed desorption, and more recently oxygen isotope exchange to look at how oxygen adsorbs, dissociates, and goes into the lattice in a variety of different cathode type materials. And you can see the results of this here. This is for lanthanum strontium manganate, and again, Since the gas phase is oxygen 18 and isotopically labeled oxygen, and the solid phase is oxygen 16, it allows us to see that the oxygen 16 coming out of the lattice and the oxygen 18 going into the lattice and the formation of a scrambled product due to oxygen dissociation on the surface, as shown here with the oxygen 18, oxygen 16. And this is the case for lanthanum, strontium, cobalt, iron oxide. And it allows you to understand what is the mechanism, what are the steps. It shows the well-known fact that lanthanum, strontium, cobalt, iron oxide is a much more active catalyst, but it gives us mechanistic understanding between the incorporation of oxygen into the lattice and the dissociation of oxygen in the lattice, and indicates that lanthanum, strontium, manganate is very good for dissociation, but it's rate limited by incorporation, whereas lanthanum, strontium, cobalt, iron oxide is very good for incorporation, but it's rate limited by dissociation. And so again, this gives us an understanding to be able to develop new cathode microstructures based on the fundamental kinetics involved. We've also focused on anodes and the advantage of solid oxide fuel cells and fuel flexibility, and under support from the Office of Naval Research demonstrated that we can run on JP5 reformate with only about a 20% drop in power density as compared to hydrogen, and then the fact that these are quite stable here at 550 degrees C for 500 hours of operation running off that JP5 reformate. And moreover, the issue at low temperature with solid oxide fuel cells, again below 600 degrees C, is the concern of coking. And in fact, there is no carbon deposition with solid oxide fuel cells at those temperature range. And it really opens up the opportunity for hydrocarbon-fueled fuel cells as we transition sometime into the future for hydrogen. And really opens up a lot of opportunities for fuel cells, as I said, to cover the spectrum of applications in that quadrennial technology review. So more recently, we've been able to integrate some of these techniques and both the bilayer electrolyte and enhanced cathodes, and basically double the power density, receiving 2 watts per square centimeter at 650 degrees C, which, as Mark indicated, is one of the highest power densities achieved. If you put that in perspective, here 2 watts per square centimeter corresponds to 10 watts per cubic centimeter, extremely high power density. And if you look at it on a gravimetric basis, you just multiply by the densities, and that corresponds to 3 kilowatts per kilogram. So on the drive for electrification of vehicles, a lot of people look at this energy storage figure of merit. And this is a Ragone chart of specific energy on the y-axis and specific power on the x-axis. And you can see all of the different types of batteries that are out there, and the Department of Energy's goals for hybrid electric vehicles, plug-in hybrid electric vehicles, and electric vehicles. And of course, in all of these cases, they're trying to get to the internal combustion engine, because if you can achieve the power density of internal combustion engine, then the use of electric batteries and electrification of vehicles is transparent. Now, fuel cells are relegated to something a little bit lower. It's got this nebulous cloud because it's based on hydrogen, which has a lower energy density. But if you can run off of hydrocarbon fuels, you have the ability to have the same energy density as internal combustion engine. At 3 kilowatts per kilogram, we actually have a higher power density at the stack level than internal combustion engine. But since fuel cells have much higher energy efficiency, the fact is we can potentially get higher range than internal combustion engine also, really driving the transportation sector towards electrification. Now, this was the other, of course, issue with fuel cells is cost. And this is a plot from DOE Fossil Energy focused on solid oxide fuel cells. And you can see the drop in cost of the stack from $1,500 a kilowatt to $175 a kilowatt, where we are sort of today. And then you see that it plateaus out. Now, the transition there is not because of any fundamental limit to continue to drop the cost. Rather, it's a focus on the transition to coal applications and the focus programmatically to try and use solid oxide fuel cells for coal-fired power plants. In contrast, EERE has focused on the electric vehicles, and therefore cost is a bigger driver. And through significant advances in electrolyte, but more importantly in reducing the platinum loading of the electrodes, they've been able to project a power cost of about $51 a kilowatt, and that's the current target today. Now, I can go back to the solid oxide fuel cell data and say, well, rather than limiting the power density to sort of the half watt per square centimeter it was at that target, and just extrapolate to what the power density we've achieved today, and that brings the price down to around $44 a kilowatt. So there's a lot of room for developing solid oxide fuel cells at lower temperature, running off conventional fuels and achieving cost goals that are not really being targeted by the agencies today. And when I published this in Science and Energy and Environmental Science, it actually got a lot of press, like Scientific American, Technology Review, and actually Technology Review made it one of the highlights of the year in 2011 for the year in energy. I still haven't gotten any DOE funding for making the scaling up the cells, but luckily we've been able to start a new company, Redox. We have investors in that. And I look forward to being here next year and showing us stack data. So I need to thank the sponsor of the research, again, Kevin Christ, GTI, for giving me the first opportunity to develop these cells. The SECA program for a number of different advancements in electrolyte, cathode, and other things. NASA, ONR for the funding to actually make the cells that demonstrate the high power density. Redox, where our support is today, and of course all of these students, postdocs, and collaborators I've had the opportunity to work with over the last couple decades. Thank you.
Please welcome Program Committee Co-Chair Michelle Anderson.
Hi, I'd just like to congratulate Eric again on his award. And in addition to all of his scientific and technical contributions, he really has an outstanding legacy. All of the methods he described, the students and postdocs that he have trained, they're applying those methods and building on them in their own independent academic and industrial careers. So it really is an impressive legacy. The development and broad-based adoption of fuel cells and new energy technologies certainly requires the scientists and engineers who conceive, embody, and demonstrate those capabilities. But equally important are the non-technical visionaries with passion and energy equal to their technical counterparts. People who are capable of explaining the benefits of including fuel cells and hydrogen technology in the development of national and international energy strategies that provide clean energy and energy security. People who build coalitions that lead to tangible results in terms of securing resources for fuel cell and energy technology development and advocating for and enacting policy that fosters broad implementation and growth of new energy technologies. Congressman Robert S. Walker is one of those people. Congressman Walker retired after representing Pennsylvania's 16th District in the U.S. House of Representatives for 20 years. During that time, he was chairman of the Committee on Science and Technology, chief deputy whip, vice chairman of the Budget Committee, chairman of the Republican leadership, and speaker pro tempore. Presently, Congressman Walker's longtime involvement in alternative fuels and climate policy have made him a recognized world leader in this arena. From 2004 to 2011, he was a member of the U.S. Department of Energy's Hydrogen and Fuel Cell Technical Advisory Committee, where he served as its chairman and vice chairman. For more than 30 years, Congressman Walker has played a key role in the development and implementation of major public strategies related to science, space, technology, energy, and legislative procedure. It is with great pleasure that I present the 2012 Fuel Cell Seminar and Energy Expedition Award to Congressman Robert S. Walker.
Please welcome the 2012 Fuel Cell Seminar and Energy Exposition Award winner, Congressman Bob Walker.
Sun is shining in the sky. Well,
thank you very much, Michelle. That was a very nice introduction, and I really appreciate it, and I appreciate this prestigious award. Thank you very much to all of you for recognizing me in this way. I am a little bit reminded of a time when I was out speaking and I was introduced as a great, great, great American statesman. And I felt pretty good about that, and I said something to my wife on the way home in the car. I wonder how many great, great, great American statesmen there are. She said, one less than you think. But I am the person here who comes at this from a public policy standpoint, and it largely is a result of my being assigned to the Science Committee when I first went to the Congress. It wasn't one of the ones I chose, but they assigned me to it, and I found it to be fascinating. Now, I'm a little like Tom Sullivan. I had several college professors who had taught me science who had mild heart attacks at that time. But I found it to be a fascinating way of being able to look at America just over the horizon. If you began to understand the technologies that were going to drive the future, you began to understand the changes in culture that would take place. And if you understood the changes in culture, you began to see how public policy and politics were going to have to be reframed in order to deal with a lot of that. And think, for example, of how far we have come in computer technology over the last few years. So about 30 years ago, I really began to look at the whole energy sector. We had responsibility for energy research and development at the committee. And I came to the conclusion that hydrogen was one of the places that we needed to look. And the reason for that was geopolitical. It was in efficiency applications. It was in its supply. It was in environmental integrity. And it was in the whole concept of distributed supplies, distributed power, which had national security implications. And what I found was that a lot of the work that had been done in that area was moving us in a new direction, but there were still major issues that had to be overcome that had public policy implications. Cost, for example, infrastructure, for example. And so one of the focuses I had in this was the whole transportation piece, because that was a place where the use of energy had long-term applications for the country and implications for the country. And so I began to look at that, in part because, as I say, I was fascinated by the fact that it was transportation, and secondly, because I'm a race car driver, as one of my hobbies. And one of my mottos out of race car driving is my friend Mario Andretti, who one time said, if you're in control, you're not going fast enough. That's the world in which we live. And the fact is that as you looked at where we were headed, it was clear that if we didn't get in the lead in some of these areas in transportation, the rest of the world was going to catch up with us, and we would no longer be in control of our destiny in that area. One of those areas was electric vehicles, because there's no doubt that in terms of efficiency, electric vehicles have great advantages. They are kind of a big appliance, and that also makes them more efficient in terms of manufacturing. And so the car companies, who many people think will never want to move toward these new paradigms, it's not true, because they see some opportunities for them in the manufacturing side that are huge. And so we are, in fact, seeing a lot more development of electric vehicles. But it seems to me that what we've come to is an inflection point now in where we're going to head with electric vehicles, and particularly where we're going to head with fuel cells and hydrogen vehicles. The reason for that is because I think there's some new enthusiasm for the idea of fuel cells. It's represented by the fact that you're going to have 1,000 people here at your conference. But it's also represented by the fact that people now are looking at this in a little bit differently than they did even 2 or 3 years ago, because the limitations of battery vehicles are becoming more and more evident. You know, it's one thing to have a range of 120 miles or 150 miles on a test track. It's another thing to do that when the car is in actual use on the highway. And so the battery limitations are becoming something that is being recognized, again, in the public policy sector. And then you also look at the fact that we now have vast supplies of natural gas that are becoming available to us domestically. Now, natural gas was not something we could talk about in terms of fuel cells a few years ago, because the immediate answer was, well, that's a very limited supply. You can't begin to think about that. Well, the fact is the natural gas route is a route to hydrogen supplies that are relatively inexpensive. And now, with supplies of natural gas, we can now begin to think about that in ways differently than we ever have in the past. Now, so that gives us 2 inflection points. We need the electric vehicles. The batteries are not optimal. The range of vehicles on fuel cells allow us to have electric vehicles that are compatible with how people generally want to use their cars. And we have the efficiency that comes from the fuel cell that allows the cost of providing that fuel to the family of being very near to what they're used to now, or maybe even less. Now, it's also true that the fuel cells are ready. A lot of the automobile companies have put a lot of time and effort into developing cars that run on fuel cells. And so you have Daimler, you have Hyundai, you have Honda, you have Toyota, you have GM. A lot of them have developed fuel cells now that can be regarded as reliable, robust. And so we are at that point when the chances of moving ahead are quite good if you look at it strictly from the technical side. However, we still have the problems that were recognized 30 years ago, and that is cost, and that is infrastructure. And those are things where public policy is going to have some role to play. You know, one of the things that we need to look at is whether or not we can begin to use that natural gas in a more efficient way than doing it strictly by going to cryogenic at refineries and shipping the hydrogen by truck to fueling stations. If in fact you could use the natural gas infrastructure that's already in place in the pipelines and use those pipelines going to the stations, that would make a huge difference. And what we can now begin to imagine is, for instance, using small reformers at gas stations across the country or at minute markets across the country, and use those reformers as a way of beginning to get an infrastructure in place. Ultimately, of course, all of us would like to go to green applications along the way, but this is the transition that allows us to get to the efficiency of electric vehicles. I just think we're at a point now where all of you can make a difference. At the great musical Les Miserables, they end the entire thing by saying, "The future's what we bring when tomorrow comes." Well, the fact is that energy's future is just over the horizon. It is tomorrow. And tomorrow is where all of you can provide leadership for the future. The leadership that will bring fuel cells into play, that will give us the kind of geopolitical efficiency and supply, environment, and distributed energy, national security that I was looking for 30 years ago. I thank you for all that you're doing to make this possible. I thank you for this prestigious award. It's a pleasure to be with you.
Please welcome back to the stage Mark Williams.
While they can share the night, it goes on and on and on and on. Strangers wait.
And night goes on and on and on. It reminds me of some of the evenings I spent in Japan. We're a different time zone. But Congressman Walker, thank you very much. Everyone here deeply appreciates all you've done for fuel cells and hydrogen over the years. Now it's my pleasure to introduce Ariana Callion. She's the Vice President of Engineering and Operations at UTC Power. She oversees all the engineering activities at UTC Power. She joined UTC after 19 years at General Motors, where, among many other things, she helped roll out the 2006 Buick Lucerne. She's a graduate of Cooper Union, Columbia University, and RPI. Join me in welcoming Ariana Callion.
Please welcome from UTC Power, the platinum sponsor of the 2012 Fuel Cell Seminar and Energy Exposition, Ariana Callion.
Just waiting for the presentation. There we go. Great. Very good. Well, it is a great honor to be here presenting at this year's Fuel Cell Seminar. This morning, I'd like to spend some time discussing the role of fuel cells as an element of the solution to meet our energy needs, reliably and sustainably, today and in the future. As we're all aware, growing energy consumption associated with the great amount of population growth we are experiencing is indeed a global problem. The U.S. Department of Energy estimates that global energy use will jump over 50% between 2008 and 2035. We need to consider alternative means to meet our energy needs beyond the traditional centralized plants and seriously investigate sustainable forms of energy production produced nearer to the point of use. These alternative technologies need to be clean, reliable, and of course, affordable. As we consider energy usage, we look to the infrastructure of a city, a state, a region, and to the two primary users of energy: its building stock and the means of transportation available to its citizens. In the U.S., energy consumption is primarily driven by buildings, commercial, industrial, residential, as shown in this chart. By offering distributed generation for commercial and industrial customers, fuel cells can impact as much as 50% of the energy demand in the U.S. Further, fuel cells can also provide a tremendous benefit in the transportation space. Along with the rise in energy consumption, the cost of energy generated by traditional means has risen, as you can observe in this graph. Electricity in particular has experienced a marked increase in cost. And along with the increase in financial cost, the cost to the environment has been significant, with increases in the level of carbon dioxide. So as we know, the problem is indeed clear. We do have options, however, for our future. Alternative energy sources relying on distributed generation can provide solutions, and the benefits are multifaceted. Industrial and commercial customers, who again represent as much as 50% of energy demand in the U.S., are looking for alternative energy sources for three primary reasons: energy productivity, energy security, and energy responsibility. By generating energy at the point of use, power can be generated independent of the grid. By efficiently generating power from natural gas, emissions are reduced, as well as energy cost to the customer. And not insignificantly, the environment benefits as well. A balance of technologies really can be an effective technology solution. Solar, wind, and fuel cells can together work in concert to help solve our global energy problems. Fuel cells, as you know, are a proven solution to the energy challenges that we have, providing energy-intensive facilities with lower energy costs through superior efficiency, energy security, and reduced emissions for responsible environmental operations. Fuel cells can, of course, be installed on their own, but they can also be installed in concert with alternative energy options to provide more of a building or a site's energy needs. And I'll provide an example of that a little bit later. Two critical reasons for the benefit of fuel cells as part of our energy solution are availability and annual carbon dioxide reduction. As you know, fuel cells generate electricity 24/7, 365 days a year, regardless of weather conditions. So by generating both power and heat from natural gas, fuel cells can therefore reduce significantly the amount of carbon dioxide that's produced. Additionally, flexible siting and a small footprint allow for greater installation flexibility, making fuel cells usable in a variety of projects, especially in applications where solar and wind installations aren't particularly practical or viable. Indoors and very cramped urban locations are prime examples for the flexible benefits of fuel cells. So in spite of our commercial progress as an industry, there remains a tremendous opportunity for fuel cells to be a much larger part of the national energy mix. Customer acceptance and awareness are increasing in key markets, but not in all, where the industry has not yet experienced that type of growth. There is a tremendous amount of untapped growth ahead, and we can all play a part in how to make that happen. In stationary applications, fuel cell solutions work best when the building can baseload nearly all of the power and thermal energy. Typical market sectors that fit this profile best are data centers, hospitals, educational institutions, office environments, and utilities. These sectors are generally very energy intensive. They have power, heating, and cooling needs, and they value the clean energy and the reliable power attributes that fuel cells provide. The fact that fuel cells are a clean energy solution can contribute to sustainability, or the green goals that many corporations are now including in their short and long-term planning. Beyond providing the demonstrated benefits, fuel cells can also provide leadership in energy and environmental design points, and also provide the right messaging to a company's stakeholders about their commitment to sustainability. So let's talk about a few of these markets in more detail. Hospitals are an excellent fit for fuel cell systems. The 24/7 demand for power and heat allow the power plants to operate at their most efficient point. The grid-independent capability provides power during grid outages, and as many hospitals are space-constrained, the flexible installations are a welcome bonus. Here we've highlighted two of our hospital installations in California and in Connecticut. It isn't easy to bring green technology to an urban setting. There isn't enough real estate for large wind or solar installations. But because of the flexible installation of the pure cell system, companies can go a long way towards meeting their sustainability goals. Here we've highlighted two installations, CBS Studios in Television City and Studio City, California, and Beacon Capital in New York City. This particular building is on 6th Avenue in Manhattan, and the fuel cell provides heat and power for the TV studios. It's an indoor, sub-basement installation in arguably the most urban setting in America. Outside the U.S., the Korean fuel cell market is growing rapidly. Shown here is one of the largest fuel cell installation sites in the world, with 12 UTC Power fuel cells, 4.8 megawatts of power, provide electricity and heat to the people of Anyang. San Diego Gas and Electric is also using a pure cells fuel cell to provide power for themselves and heat to their host site. In addition to utilities, we have several private customers that we're exploring the use of pure cell product for microgrid applications, as Commissioner Smith mentioned earlier. And we expect to see this sector grow in the future. As mentioned earlier, fuel cells can be installed on their own, of course, but can also be installed to work in combination with other alternative energy sources. This can enable a site to have a greater amount of energy provided from alternative sources. So here is a theoretical example of how to combine these two technologies. So we start off with the building. And as you can see, the building is gaining its energy from the traditional centralized electricity power plant. So the next step is adding some photovoltaic cells and having a solar installation provide energy during the peak hours of the building energy consumption. And on top of that, adding a fuel cell. And the fuel cell could be added in parallel with a solar installation, meeting the base load of the building, while the solar installation provides the peak capability during the daylight hours. This really can be a very effective multi-technology solution, and indeed, it is in place at a site in New York City. This is an actual example of such a multi-technology solution at the Octagon building. It's a 500-unit residential Becker & Becker property in New York City, including 50 kilowatts of solar installation, as well as a 400 kilowatt Pure Cell 400 fuel cell, working together to meet the building's energy needs. The 400 kilowatt fuel cell provides 90% of the building's needs, and of course that is continuous power. And on top of that, the 50 kilowatts of solar installation provide additional energy on an intermittent basis. The market response for the technology has been very strong across the board for those who are indeed first-hand users of the products, as noted in Becker's comments, which I'll read. So I think it's very important to hear firsthand what actual developers are experiencing with the product. Fuel cells provide the energy trifecta of distributed generation, combined heat and power, and homegrown innovation, and will be an increasingly important technology for the multifamily housing industry as building owners, investors, and tenants realize the economic and environmental benefits they offer. Shifting gears to the earlier topic of transportation, I'd like to spend some time talking about fuel cells in transportation applications both in automotive and in transit bus fleets. As you've heard a little bit earlier, fuel cell vehicles do indeed have applicability across broader fuel automotive markets, and those are based on 4 key areas. The first, fuel cells can be refueled fairly quickly. Fuel cells can provide internal combustion engine equivalent range, which we don't see in other technologies. Technology and cost can be spread across many vehicle classes and not just focused on subcompact or compact level vehicles. And lastly, drivers do not have to compromise or sacrifice amenities as with other alternative powertrain technologies. And of course, over the past years, technology issues have been resolved, are being resolved as we speak, and costs are projected to decrease as automakers prepare for near-term series production. The billions of dollars that the auto industry has spent preparing for the future of fuel cell electric vehicles can be seen by this list of OEMs, as Bob Walker noted just a few minutes ago. They have near-term production launches planned and are committed based on the work that they've been doing and the progress they've been making. Moving on to transit buses, let's take a minute to review the real-world efficiency data of some alternative transportation power plant technologies. In the early stages of deployment, small fleets of fuel cell buses can readily provide an efficient solution for the transit agency. Large-scale implementation of fuel cell buses can have both a market improvement in the fuel economy of the fleet as well as in local air quality. And so let's take a look at a market snapshot of what's going on with transit buses. UTC Power's Pure Motion system is deployed in the U.S. in revenue service, and over the past several years has had great fuel cell availability of over 95%, which is comparable to any other type of bus that's in transit operation. The fleet leader is running a 12,000-hour cell stack on the original cell stack, and the durability remains strong. We have a fleet experience of more than 600,000 miles, and so our partner transit agencies are very pleased with performance. One of those is AC Transit. They've been very pleased with the performance of the product, and the end customers are also very satisfied with the service they derive. They recently conducted a survey of passengers to really understand true customer feedback, and overwhelming the response was very positive. 84% had a positive view of the fuel cell program. 70% said it improved their opinion of local government for making the choices. 90% felt it was important to consider alternative fuels in the fleet. And most importantly, over 80% were in favor of expanding the fuel cell bus program. I trust that this morning's discussion of fuel cells as a solution to our nation's energy needs, energy independence, and environmental concerns will give us the motivation to help educate the broader population in the benefits of this technology and its readiness to implement today and into the near future. Thanks very much.
Please welcome back to the stage Mark Williams.
They can share the night, it goes on and on and on and on. Strangers.
Thank you, Ariana. It's now my pleasure to reintroduce Tom Sullivan, the 2012 Fuel Cell Seminar and Energy Exposition Conference Chair. And if you read his bio, it's very interesting. It's two-time Entrepreneur of the Year in Virginia. He's a trustee for the National Braille Press. And as Shannon mentioned, he launched the Proton Energy Scholarship Program, which is supporting education with some $2 million in awards for outstanding students. And entrepreneurs in the audience, the fuel cell entrepreneurs in the audience, I would listen to his remarks closely. I think we're in for an excellent presentation. Tom?
Proton On Site is a 2012 Chairman's Pledge sponsor. Please welcome back Tom Sullivan.
Thank you. Again, great to be here. People always ask how I got from hardwood to hydrogen. In 1993, I started a company called Lumber Liquidators. This was after since high school I was a contractor and over the years I tried many different things. But I had started buying and selling excess lumber. Started Lumber Liquidators in the back of a beat-up pickup truck behind a trucking company outside of Boston, Mass. We now have about 280 stores around the country and Canada, selling all hardwood flooring now. 1-800-HARDWOOD if any of you need a great deal on hardwood flooring. I gotta change this thing. That was our first store. That was actually our more fancy store after the trucking company. What you can't see there is there's a porta potty on the parking lot, which is still there today in our store, and our headquarters was upstairs. But we kept the costs low and the prices low, so it worked well. But prior to going public in 2007, I had hired a CEO to run the company. And that left me more time to do what I really like doing, which is not always a good thing, but starting new businesses. One thing that had always bugged me was the archaic way we fuel our cars. It seemed ridiculous that we're still pumping oil out of the ground to put in our polluting vehicles. With all the technology and all the smart people we have here, I thought there must be a better way. So on and off for a couple years, I had been looking what could be the next fuel. And what I decided made the most sense was hydrogen. And if you could make that with solar or wind, you couldn't get much better than that. So one Sunday morning in July of '08, I Googled solar-powered hydrogen. And a New York Times article came up and mentioned a house in Mike Stritke's house in New Jersey. Everything was powered with hydrogen. The car, the dryer, the heat, the stove, and he made this with solar, and in the article it mentioned Proton Energy, made the electrolyzer for this system. So then I looked up Proton Energy and found out they were getting auctioned off on Tuesday, part of a larger company that had gone bankrupt. So after extensive due diligence on Monday, I put in a bid on Tuesday and ended up owning a hydrogen company. At the time it was called proton energy, and one of the first things we did was change what I thought looked like a lightning bolt logo to a more consumer-friendly logo. And we changed the name to Proton Onsite to better describe what Proton had evolved into. The company is still run by one of the founders, Rob Friedland. I'd also like to congratulate Rob on, we just won one of the top 20 companies to work for in Connecticut. So good job, Rob. Thank you. But as I learned more about the hydrogen business over the next few years, came to realize that the fueling part, the people weren't building the cars because there was no infrastructure, and the infrastructure wasn't being built because there was no fuel cell cars. So I figured someone had to start building some stations. So we built the first station in the parking lot of Proton's headquarters, just off of the highway. Here's a picture of what the station looks like. What seemed like science fiction a few years ago is right now a reality, right down the road from here in Wallingford, Connecticut. Customers can pull up in a hydrogen car, swipe their credit card, fill up in about 2 minutes with fuel that's made by sun and water, and drive another 300 miles with 0 emissions. The stations are pre-made and containerized that require very little on-site construction. These stations can be placed in the parking lot of an existing building, like lumber liquidators buildings around, with the solar panels on the roof and the station in the parking lot with a proton electrolyzer. Toyota has put about 10 fuel cell cars around the Wallingford area that use this station, but we need a lot more to make it successful. We plan to open a few more in the region over the next couple of years as the more cars come about. With the technology that we have today, like this, which is really a reality, it's crazy that we spend $1 billion a day importing foreign oil. We should be working towards mass producing and perfecting hydrogen stations, fuel cell cars, etc. for the U.S. and exporting this technology around the world, creating good high-tech jobs right here in the U.S. And even though hydrogen fueling is why I got into this business and why Proton initially got started, one of the things I liked about Proton from the beginning was it didn't rely on hydrogen fueling to be successful. We make equipment for labs, power plants, and many other industrial uses. Even the NASA space station will soon have Proton equipment on it. We are currently developing a PEM electrolyzer, which will be the largest in the world, a 2 megawatt electrolyzer. The primary use will be to make renewable energy storage for solar and wind more efficient. So as long as the time it takes for the fueling to come about, Proton will be there and be ready for it. And like someone said before, a mix of scientists and business people is what's needed to get hydrogen moving. Dr. Washman's talk I understood from the beginning to the end. The beginning when he said hello, and the end when he said goodbye. But, you know, we need to make hydrogen with using less energy and better ways to store it. And how you guys get there doesn't matter. You guys make it, we can sell it. And at Proton, we have some of the best people in the industry. But to compete around the world and to continue leading in developing high-tech products and industries, I believe as a country we need to put more emphasis on science and technology in our schools. 3 years ago, we started the Proton Onsite Scholarship Program, and since then I've awarded $1,700,000 scholarships to financially needy, incredibly talented students. And today I'm proud to announce a new Proton Scholarship Program. Students will be challenged to design or make hydrogen devices using hydrogen made from water and renewable energy. Proton will provide a scholarship to the winner or funds to develop the product into reality. Obviously, there are safer and easier investments that I could make with my money, but if I can help jumpstart the hydrogen business and fueling and get rid of oil, making wind and solar more efficient really could make a difference in the world, and it doesn't get more rewarding than that. Thank you, and go hydrogen.
Please welcome back to the stage Mark Williams.
While they can share the night, it goes on and on and on and on. Strangers waiting.
Well, they didn't know it, but they set themselves up for a longer Q&A. So I think they're up to it. They're up to a Q&A here until about 10 to 11. It's remarkable how the fuel cell industry, the spirit of this industry can be felt in this room. I've been with fuel cells many years, and it's always been a very remarkably close family. I've got a few questions we can get started off with, and one of those. So I'll ask a few questions to get the Q&A started, and then the audience here, this is a great opportunity. You have three individuals though they have common experiences, they're from very strong different areas. You have an academic, you have an entrepreneur, and you have a solid corporate business person. So you have three really good Q&A panelists. One of the first questions I have is for Ariana, and she's a model for all of us who want to be engineers, She's a professional engineer. She understands engineered power systems very well, and I wanted to ask her what were the greatest challenges in engineering new fuel cell systems for stationary and automotive applications. Ariana?
That's an excellent question.
Do we have to... Here, sir.
Can you hear me now?
Oh, yeah, Mike. Yeah.
It's an excellent question. And there are a couple of different areas to talk about challenges in fuel cell development. I'll start off, as we all are, striving for improved cost position. Everything that we do is about improving performance, improving reliability, and ensuring that our costs can be driven down as quickly as possible to provide for the best value proposition for our customers, because that's really how we see we can make an impression and make a significant change in the way we're able to deploy in volume our products. So that, I think, is a sort of global across all of our vantage points from the fuel cell industry. That will remain a challenge, but we're certainly on the cost curve coming down and have proven successes in cost reduction for the product. I'd also say that as we enter new markets, particularly in the stationary fuel cell arena, we are oftentimes challenged understanding what the end customer needs are, because they don't know necessarily that they need it, and so we are working with them to establish what the best way to deploy the product in their site, at their installation, and ensure that it can make the most benefit for them, both financially and from an environmental perspective as well. So those are a number of the typical types of challenges we face. Of course, it's a lot of aspects are very similar in production of and development of other products. We go through the product development life cycle, and that is very typical of many other commercial products. And I think, as we've all spoken about it in different ways today, the products are commercial, and it's just getting them out there in more volume and getting them more accustomed to the population at large. It's easy for us to speak about it, but it's getting to the broader population for their acceptance.
Thank you, Ariana. Is there anyone in the audience who wants to ask her or any further to elaborate on that? If so, they can come to the podium. If not, I'll ask a second question, this time for Eric. You know, Eric's been in academia 25 years. It's a research business he's in and education business. And, you know, how has student interest in fuel cells changed over the years, and where is it now?
So I've been a director of 2 energy centers, both at the University of Maryland now and the University of Florida before that. And the interest of the students in energy has always been high, and as a matter of fact, I've just seen it continue to increase. The issue is within that increasing interest in energy as something they want to get into, it's the technical focus, and that tends to vacillate with the public press. You know, there's always a groundswell of students who want to do solar, but you've seen this thing sort of a trade-off between batteries and fuel cells in recent history, and that has shaped what the students are interested in, because they see that, you know, they're looking at this as a career path. Having said that, I always have students coming to me wanting to work on fuel cells. I have more students coming to me asking to work in my group than I can possibly afford to support. And if the resources were there, I would love to have many more students to continue. But there has been a constant level of interest. It does vary with what's in the popular press, but there's a continued increase in fuel cells.
Okay, Eric, thank you very much. Get your questions ready in the audience, and while I ask Tom a question, it's burning with me. What made you an entrepreneur? I mean, why are you different? And what advice can you give the fuel cell entrepreneurs in this audience?
I don't know what made it to me. My mother says the first time when I was about 3, my sister had a brand new bike, and mine was old and rusty, and I talked her into giving her bike and trading the bike. So she said it started very young. And I think it's just born into you. I would always, whatever, cutting grass or shoveling snow, I love to see snow because you get the day off and you can make money. So it was, but I was always interested in business. I don't know exactly why. And then I always kind of had an idea of doing something with this once I had created a business that was successful, and to get into science and do something that could really make a difference.
What kind of advice do you have for the fuel cell entrepreneurs here?
It's a hard business. I'm glad I made money before I get into this business. So. But just have to keep pushing. I mean, even when the hardwood flooring business, it was very low tech, of course, and we were in just in an empty warehouse without even plumbing. But in some days, it would feel like at the end of the day you're in the ring with Mike Tyson, and at the end of the day, and you're ready to give up. But the best thing is never give up and keep pushing however you can. And I think what the congressman said, if you feel you're in control, you're probably going too slow or not trying hard enough, and just keep trying different things till something happens.
Appreciate that very much. All right, we can start taking questions from the audience. I hope you have your questions ready. We have our first. Please come to the microphone in the aisles for your questions and identify yourself and direct your question.
Hi, my name is Tim Dolan, and I'm going to address it to you and the rest of the audience. Can any of you name one thing in your life that has not been touched by fossil fuels? Come on, just one thing. We have a whole room full of smart people here.
The hydrogen that comes out of our station at Sun Hydro and Proton.
There you go. And now the next question is, where are we going to get our energy from for the next 7 generations? Thank you very much.
You all want to take
hydrogen?
Eric, you want to start?
I didn't quite get that question.
I guess it was more of a, the question was, where are we going to get our energy for the next 7 generations, I think.
Ultimately, we're going to get it from the sun, because ultimately that's where all of the energy in the earth came from in the first place. It's how we do that. How do we transition to that without having disruptions in the economy and standard of living? So, you know, we have a hydrocarbon-based economy today. We'd like to have a solar one in the future. I think we're all in agreement on that. It's a matter of how we make that transition. So it's going to be a mix of things for some time to come.
Ariana?
I'd agree that there needs to be a roadmap for the future to get us from our current situation to a future position, and it's not a trivial task from either a vision standpoint or an execution standpoint to lay out that roadmap and then to be able to have an end in sight.
I just want to add that that would be a real energy policy.
No, I would agree with Sun also, but it may be something that we've never even thought of or it hasn't even come about, and I think that's why we need to focus on having a good energy policy and putting money towards education and developing more scientists, engineers that come up with something that maybe no one has ever thought of before.
Okay, our next question from the audience. Shannon?
Hey, Shannon Baxter Clemens with the South Carolina Hydrogen and Fuel Cell Alliance. My question is, and I hope I don't get pelted with tomatoes, but there were, the cuts in the Department of Energy over the last few years have been very tough on the industry. And I think a lot of it was from a media perspective, that the federal government didn't believe in hydrogen and fuel cells anymore, and that seems to be turning around in rhetoric. Nick, there's a lot of buzz up here. I don't know if there's anything y'all can do about that. But I saw some good things come out of it too. I saw where we worked together to do things differently, found new solutions because we couldn't do things the old way anymore. I'd be interested in your thoughts on, was the cut in funding all bad? Did you find that there were good things that came out of that cut in funding? And if with the next administration, whether it's a new Obama administration or Romney administration, do you have, would you prefer to see that funding restored or restored in a different way? Or I just think this is kind of I just didn't think it was all bad. Hold your fruit, please.
Yep. Personally, I don't think we need to wait around for the government. It's good if they're behind it and so forth, but if we're waiting around for the government, it's never going to happen. If it's going to make sense, it needs to happen with private industry pushing it forward. And the car companies have done some of that, and we need more stations to make it work.
I'm going to counter that with although I agree that the funding ultimately needs to come from industry and venture capitalists and things of that nature. They take their cues from the federal government, and if the federal government decides that they're going to cut the funding, they say, well, wait a second, maybe this isn't the right thing to be in. And I see that there's a scaling back of investments occurring because the Department of Energy did do that cut in funding, and I think if it's basically just showing that they believe in the technology, even if the dollar amount is not,
No, I would agree with that.
Yeah. I'd say that relative to the success of our commercial products, the ability to have increased volume and increased market acceptance of the products will, in and of itself, make a tremendous benefit for the future and for our ability to internally fund future developments. Clearly, advanced research and advanced programs do, in many cases, really benefit from the governmental funding, but we really want to make our industry self-sustaining because of being able to drive volume and to drive acceptance and broader market penetration for the products in comparison to non-green products that can do similar, provide similar impacts or benefits to customers.
Okay, we have another question in the back.
Yeah, hi. Peter Hoffman from the Hydrogen and Fuel Cell Letter, and it's for Tom Sullivan specifically. Tom, whatever happened to your plans for the string of hydrogen stations along the eastern seacoast? You built the first one in Connecticut, which I actually wrote about in our newsletter, but then things became very quiet. So what can you tell me? Is this on hold? Will it be revived, or are there different plans? Thank you.
Yes, the original idea was to build stations from down the East Coast, but after looking at it more, it didn't really make much sense. It's better to have a cluster of them. So we plan to build that in the Northeast, where most of the traffic is not driving up and down the East Coast, but within one area. And one thing we do need is more cars, which they are coming, but we will have a new station in the Boston area within probably about 6 months, and then more as we get the cars to make it a little more worthwhile.
Okay. Tom Benjamin.
Yes, I'm Tom Benjamin from Argonne National Lab. This question is addressed to everybody up there. I wonder if you can comment on the international competition. We saw a list of all the car companies. Are the other guys ahead of the United States? Is there more penetration of residential CHP in other places? That kind of thing.
Yeah, I mean, it seems like Germany and Japan are getting ahead of us with the technology and putting stations up, and that's, another reason why the U.S. should be first in this, not only for the clean energy, but to make this an industry that the U.S. is leading in high tech. One, to create jobs, but also to export the technology around the world.
The investment in some of the other countries has continued, even though there was a drop in U.S. Federal funding. It continued in other countries. After Fukushima, for instance, Japan is reevaluating their energy, and a lot of the fuel cell programs are being refunded that had actually been cut in the past. Korea, which we've heard, is really going big time into fuel cells. So they continue in those other countries, and I think that if we don't continue it here, we're going to end up in a situation where we end up buying the technology from those countries in the future.
I agree with both Tom and Eric's points. The other countries across the globe are indeed funding in different ways fuel cells and growth of fuel cells as part of their energy plan and energy mix. I think the competition is actually very good for the industry as a whole, as it is early in its infancy from a commercial deployment perspective, and it is good to have the additional competition and volume and ability to work across companies with suppliers and become more capable as an entire industry, not just a tier one, but a multi-tier industry. But we do need to ensure that the U.S. stays on the forefront from a technical basis, as was mentioned previously.
All right. Okay, we have another question coming up to the podium. Right.
Hello, my name is Daniel Betts from Enerfuel. Very, very good presentations. My question is, well, a comment to everyone, that there is a real need for fuel cells in many applications, and not all applications are low-margin applications where the price of fuel cells have to come down, to almost zero margin points. And I think that being in a high-tech industry, we should be striving to fulfill those applications. And actually, we see already fuel cell companies taking advantage of that. Actually, just with Hurricane Sandy, there was a report that came out that 25%, after a week of the hurricane, 25% of cell phone towers were without electricity. And this is a huge loss of revenue for telecom operators, etc. And similar things happen in hospitals and in gas stations, etc. So there's a real value proposition for fuel cells that batteries and internal combustion engines can really not compete very well with. And I think that our industry needs to start orienting itself towards those high-margin early markets, and it's a question of breaking through to them in a concerted effort. Thank you.
I'd agree that a lot of it is education and awareness, because we still find it amazing that the broader industries who need the type of power that you described in multiple industries are not as aware as we would hope or would have believed that they are about what products are commercially available and how they can benefit them immediately from a revenue standpoint and then provide additional environmental benefits on top of that. So it is definitely something that, as an industry, to be able to get out into the broader public and have this become the comments of wind, solar, fuel cell becomes almost a phrase rather than wind and solar, perhaps, to be able to get people more aware of the combination of the technologies and how to quickly get those deployed.
The recent storms that came through, all of them, the models and the evidence is that that's just going to continue to occur more frequently and with greater impact. And I hate to say it, but that really is a major opportunity for fuel cells, for distributed generation, for microgrids at multiple different scales. And the industry needs to take advantage of it and market it towards that. And particularly now with the abundance of natural gas as a fuel, there's a lot that the industry can do to capture, the energy security requirements that those industries that have a premium for reliable power, but just in general. I mean, you can't go and have no power in a community for a week without having major impacts. So I think there's a tremendous opportunity there for the fuel cell industry.
Any other comments from the panel? Next question.
Thanks, Mark. This is Jeff Surface, Technology Transition Corporation. Energy storage, very, very important topic for handling renewable energy, larger amounts of renewable energy. Hydrogen, fuel cells, and electrolyzers are all components of a potentially of energy storage future. If we were at an energy storage conference, those topics would typically not be a part of it. I'm interested in the panel's views of how we ought to be making inroads and actually developing hydrogen for large-scale energy storage for the integration of renewables and other grid benefits.
Yes, we see that as one of the big opportunities coming ahead to make wind and solar more efficient with hydrogen storage and fuel cells.
Ariane?
No, it's true. I think there's a clear need for energy storage, and as Tom mentioned, and if you think about the preponderance of solar and wind sites that are being built up across the globe, it's not clear how they can be more effective if they also were coupled with storage rather than standalone.
And in that storage, again, there's a lot of different aspects of storage. There's sort of a diurnal long-term storage. There's transient when they start getting into some of these different markets where they look at power fluctuations. And one of Ariana's slides, which I liked, was basically showing, the fuel cells providing base load and allowing for the renewables to come onto the grid. And I really think that is a mechanism for the future.
Okay, I've got a question, and please be continue to get your questions ready. You probably heard that some 5,000 trillion cubic feet of natural gas has been made available worldwide. Innovations in horizontal drilling and the interest is opening up these reserves. In this area alone, in West Virginia and Pennsylvania, New York area, there's some estimates of 1,400 trillion cubic feet of natural gas in the Marcellus Formation. But to put things in perspective, the United States only uses around 23 trillion cubic feet per year for all of its natural gas needs. So we're talking about 1,400 trillion cubic feet in just one of the natural gas basins. There are others. So this is a game-changing event. What does that mean for fuel cells?
Well, to start off, just in the very narrow scope of natural gas-based fuel cells, phosphoric acid as an example, as we see the cost of natural gas and the propensity and availability of natural gas across a larger scale, that simply can provide us with a better value proposition for customers if indeed electricity costs continue to rise at a higher rate over the coming years. That spark spread between the cost of electricity and the cost of natural gas is a key factor in the economics in the customer value proposition that we work with when we develop sites with potential customers. So that certainly can be a large enabler for a greater presence in the future.
Eric? So natural gas, again, is just a major opportunity for fuel cells for distributed generation for multiple scales, from residential through large-scale power generation. The problem is that right now, these gas turbines are relatively cheap, and a lot of the industry just looks for what's the cheapest thing to do to get something on the grid. So the case has to be made about these other aspects of the fuel cells in terms of their efficiency, so that those are deployed more than turbines in that regard. However large this amount of natural gas is, the fact is it's still finite. And if you have a finite resource, it's critical to use as efficiently as possible. So the case for fuel cells with higher efficiency means that it's going to be able to provide that energy at a lower cost for a longer period of time than using a less efficient turbine and just doing it cheaper now.
Tom, you have any comment?
I would say it's better than importing oil, but in the long run, if it can help get hydrogen going, it's good. But in the long run, if we can make it with water and not have to be drilling or fracking and all that, I think it's better to make it with a PEM electrolyzer with water and renewable, ideally.
Any comment from anyone in the audience? Wants to comment on that question? Any natural gas industry representatives here? Anyone else wants to comment on that question? The Marcellus Shale Coalition held a meeting recently in Philadelphia a few weeks ago, and one of their concerns is this gas, we need to utilize this natural gas. One of the major ways of making hydrogen is with the reforming. So how do we get to, while we might want to think about that as an industry, how do we mobilize, if indeed we want to use this fuel for fuel cells, how do we mobilize that natural gas utilization? Because that's it's a wave that's going to be hitting, and we want to be riding on the right side of that. So. Another question that I had, especially for Eric. Eric has been involved in solid oxide fuel cells for, is there a, okay, here, yeah, you want to comment?
I have a question. May I?
Yes.
Sure. Mr. Sullivan, on your electrolyzers, are you finding an adequate educated supply of technicians that could work on your PEM fuel cells and electrolyzers? Or is that a demand that's you're looking to fill?
Rob would know better, the CEO, but I believe we are finding at this time enough people that are qualified.
Thank you.
Thank you.
I can add a comment to that, not based on Tom's products, but on our products, the phosphoric acid fuel cells that we have, the PureCell 400. We've been able to find some very talented technical field service engineers or field service technicians, and we are also discussing potential for ongoing, training for technical schools on what are the important capabilities that the future students would need upon graduation where they could be field service technicians. But so far we are in actually very good shape based on what we've been able to hire.
Okay, next question.
Hi, my name is John Wagner from Sud-Chemie. I think there's a very interesting point brought up earlier was we're from Kentucky. It's 90% coal, and we're trying to facilitate a discussion on fuel cell. And what we run up against is all we talk about is wind and solar, and then there's nothing. And then also, I've read an article that's very discouraging about renewable portfolio standards that have been passed. But now that the local government, state governments are required to spend money, they're starting to delay and deny. So what can we do as an industry to overcome these really significant obstacles that I see is, number one is bringing in fuel cell into the same discussion as solar and wind, but also making legislatures in states that have committed to this to really follow through with these very important legislations for RPS standards.
All right, who wants to start?
I'm going to refer again to one of Ariana's slides where she showed CO2 reductions between fuel cell, photovoltaic, and wind. And what they're doing in these RPS standards is primarily it's concerned about climate change and CO2 emissions. So the case needs to be made that fuel cells, because they're higher efficiency, result in a CO2 reduction. And if you do that, then they should be qualifying for a lot of these rebates and renewable portfolio standards and things of that nature, which would then provide a market driver for fuel cell adoption.
Ariana?
I think Eric stated it well. Thank you.
I would say get the idea out as much as you can, contribute to your local senators and congressmen and push the idea. The more fuel cell cars and so forth that are seen around, and people just think it's something that's in a lab somewhere that's not a reality. When I take people that drive in a car, or even just tell them about it, they say, well, how come this isn't everywhere? I mean, and the car runs just like a regular car. It's just getting the word out and getting people to see it, and that's everyone has to do that as much as possible.
Okay. Now, I know a lot of people in this audience, so I have many questions up here, but I may just call on you in a minute here. So be careful. But I do have a question for Eric. Eric, you hear, the development of PEM fuel cells for vehicles has proceeded very well. But what about solid oxide fuel cells for vehicles? Are they ready, or are they ready for that application? Are there technical limitations that make them unavailable for that application? What is your opinion?
So I'm not known for not expressing my opinions. So I'll give it to you anyway, whether you like it or not. Back in 97, I believe it was, there was a Department of Energy meeting in Towson, Maryland, where they were looking at the possibility of using solid oxide fuel cells for transportation. And I participated in that meeting, and at the time, really the only place that was commercially viable for solid oxide fuel cells was Westinghouse, which again later became Siemens. And the interest was, solid state fuel cells for transportation. PEM was starting, and solid oxide fuel cells have been supported for some time. And the question came up, is that possible? And at the time I said, you just need to bring the temperature down. I realized that solid oxide fuel cells operate at a very high temperature, and it's prohibitive at the time, being 1,000 degrees C, to even consider it. But it's feasible to bring the temperature down, and that's what I've been working on for the last, again, 25-something years to be able to achieve that. And I think we're at the point where it starts becoming feasible. I know that Delphi has made their auxiliary power unit. I think that's going to be a quite successful product, but they're still operating sort of in the 700 and something degrees C range, and I've indicated a roadmap where we can get down to 300 degrees C. At the time, back that meeting in Towson, I said, well, what about hybrid vehicles? What if the fuel cell is just the range extender and you have it with the battery? And at the time they said, hybrid vehicles, that's too complicated. Nobody will ever buy a hybrid vehicle. It's too expensive. And now what happens? We've got hybrid vehicles. So I think that if you look at it from a systems perspective and you just look at it, you're going to have electric motors. What provides the power, what provides for acceleration, what provides the range, I think that solid oxide fuel cells have an opportunity there, and I think that is a market that should not be ignored, particularly, again, because we have an infrastructure right now which is hydrocarbon-based. In the future, or I know a lot of people here are pushing towards a hydrogen infrastructure. I'd like to see that, but right now that doesn't exist in a large scale. And so I think it's something that should be evaluated. I think something that should have resources towards. SECA has focused on large-scale power generation, but there really is not much support out there if you want to try and develop the next generation solid oxide fuel cells that will operate at lower temperature to open up other applications besides large-scale power generation.
Anyone else want to? Ariana?
Yeah, I would just add that the key to being able to be competitive with today's forms of transport and alternative technologies is to be able to ensure that the reliability, the long-term durability, and the costs are competitive and do not detract from the customer's experience in the product, whether that's a vehicle, a personal vehicle, whether that's a transit vehicle or a truck or what have you. So those are going to continue to be goals that we all have to strive for very, very rigorously because up until then we will always be in competition with the internal combustion engine for the knowledge that it does have that durability and that cost advantage. So that is still going to be a factor regardless of which fuel cell technology we develop aggressively.
Tom, you thinking about buying any solid oxide fuel cell companies?
No, this is enough. Enough already.
All right. Any more questions from the audience? I think it's time to...
Number 7.
Oh, where? Okay. I guess it's time to bring this to a conclusion. I really appreciate the panel, their presentations, their patience and understanding with us. There's a couple announcements we need to we'd like to thank everybody for attending because we know that the Hurricane Sandy is a hardship. 40,000 homeless in New York and 2,000 in Connecticut, and how many in New Jersey. Anyway, we appreciate the efforts you made to come here. When we exit, you want to exit from the back of the room, and there's a showroom. We can view the Toyota vehicle display. Toyota and Hyundai vehicles will be available for the ride and drive. It's our first one for the last few years, and it's Wednesday, November the 7th. It's from noon till 5:30 p.m. Toyota is a 2012 silver sponsor for the second year in a row. This room will have to be cleared. We'll have lunch in this room. So this is why we have to do an orderly exit so they can reassemble this room. I want to remind you this evening from 5 to 7 is the welcome reception in the Energy Expo exhibit hall. We will have live streaming coverage of the presidential election also. And the poster should be up before the exhibit hall opens today. So you can go from the exhibit hall to view the posters. Please join us tomorrow, Wednesday evening from 6 to 9 p.m. in Margaritaville. I heard that is really going to be a fun time. It's a fun place. This reception is open to everyone, and it's included in your registration. So we'll clear out this hall, and then at 11:30 we'll re-enter this room for the lunch. There's also an overflow area. In case you don't have a seat here, there'll be an overflow seating area in ballroom D2 where the lunch program will be broadcast live. The luncheon speaker is Senator Blumenthal. I understand he's a remarkable speaker.
And with that, I'd like to close this plenary, and thank you very much.
Ladies and gentlemen, please proceed to the showroom through the doors at the rear of the room. Please join us again in just a few moments right here in this room for the Northeast Cluster Lunch.